Okay, 9F.2, 9F.3. So we have one question here from 9F.2. So you'll notice this is very similar to what we were doing in ED when we're talking about confidence intervals for continuous random variables. We're repeating the same concepts but with discrete variables. So here today we're going to be finding how many people we need to sample to generate a confidence interval of a particular width. Okay, so yesterday we were talking about the example of 100 students playing Fortnite, 100 students at Tennyson Woods College, so N is 100, and we had 55 of them played Fortnite. And so we were asked to use that to indicate how many of them actually do play Fortnite. So we did all that. Continuing from the above example, how many students need to be sampled for the 95% confidence interval to have a width of 5%. So our proportion, our p-hat value was 0.55, and if we have a width of 5%, it means this is 0.05. 5% is a decimal, is 0.05. So it means it's 0.025 in that direction and 0.025 in that direction. So that our confidence interval is basically going to be 0.525 to 0.575. Okay? We're going to say we want a confidence interval with those boundaries. How many people do we need to sample? And this is the formula we're going to use. Okay, we have 1.96 for 95% confidence interval. That number can change depending on the level of confidence we want to maintain. So we're going to go 2 times 1.96 on the width, which is 0.05. That's squared, and we're multiplying that by p star. P star is an approximation of p, which we use, which we say is p hat. P hat's a good indication for p star. So technicality, not heaps important, but you know this is how the textbook defines it. So that's the language that we would use. So that's going to be our p hat is 0.55, and then that means q is 0.45. So let's perform this calculation. 2 times 1.96 squared. All right, I got 1,521. 21.2, so 1,521 students. Okay, and if it's 3 significant figures, we would write 15.
Do you have to round up for that?
No.
Because it's 0.2, don't you have to?
You're correct. You're absolutely correct. So when we're calculating the value of n, why do we have to round up?
Because you want to include the point.
Yeah, because we want to guarantee that width. So whenever we need to guarantee a width, we need to round n upwards. Yes, thank you. Okay, so we have 1521.2 students, or 1522 students, rounding up. And then if we're rounding to 3 significant figures, okay, then you would have to round to 1530. All right? Because, yeah, that's a good demonstration of when we have to round n upwards. That must be why I chose that problem. Okay, so that's all good. Anything I want to say about that? I think not. So we will move on to question 7. I'll just clear the board off and spin it around so we can keep that up. So 9F.3, we're going to test a claim. This is a good example of an exam question. Okay. In 2004 Australian federal election, 47.4% of voters in South Australia voted for the Liberal Party. Survey conducted in 2006 to assess whether or not support for the Liberal Party in South Australia has changed. A random sample of 80 South Australians, so this is where it's talking, and it's 80, asked whether or not they would vote for the Liberal Party if a federal election were held today. Out of the 80, 33 said they would. Okay, so look at that big fat paragraph of text that tells you about 2 things. Okay, so 33. Okay, using the sample data, calculate an approximate 95% confidence interval for the proportion of South Australians that would vote for the Liberal Party if the federal election was held today. So I'm going to go straight to my calculator for this. Okay, we're in statistics, interval, z, and first proportion. Okay, and our confidence level, 95. We've got 33 out of 80. I think I put them around the wrong way, but make sure we put them in the right way. .5, 33, hit. We've got between 0.3046, I'm going to go for 4 figures to begin with, is less than the true proportion, is less than 0.5204. Okay, we'll leave that as it is for now, we could round that accordingly. Would it be reasonable to claim this survey reveals that support for the Liberal Party in South Australia has fallen? So, in the 2004 election, we had a p-value, okay, not p-value because this is from the population. In 2004, the p-value is 47.4%. I'm getting that from the very first line, 0.474. Okay? Our confidence interval suggests we are 95% confident the true proportion of South Australia voters is somewhere between 30% and 52%. Do we have enough information, enough evidence to say it's changed? No. Okay, because this falls within the confidence interval we're talking about. So let's answer the question. No, because we are 95% confident that the true popular proportion is between these numbers, 47% falls in. Okay, what about how large a sample size is required to produce data that would result in a 95% confidence interval with a width no greater than 0.02? So we're going to do our width calculation. Do it up here. We have n is and our p value was 33 on 80. What's that? 0.4125. And times that by 0.5875. Okay, let's put down that. Very good. That is 33 divided by 80. That's our value of p hat. P hat. Yep. And then that's 1 take p. So yeah, the formula's on the opposite page. So I got 9,309.8, so 9,310. And look at that to 3 significant figures, 9,310. Yep. Okay. So let's have a go at 9F2, 9F3. We'll come around and visit everybody, see how we're doing.